Okay, number 4, a 15 kilogram package. Oh, just crossed that out by accident. Oh, I want purple. Come on now. A 15 kilogram package is pushed across the floor with a force of 85 newtons at 25 degrees. Right away, before I keep reading, I'm going to label that this will be the hypotenuse of this. So this will be my 85 newtons. It's going to be the hypotenuse. And then this is my angle. Assuming that the package moves at a constant velocity. Ooh, this is big information. Constant velocity. Find the normal force and the coefficient of friction. Okay, so I'm going to look at my package here, and I'm going to go ahead and keep doing this. I want to draw the pen. There we go. The force of gravity acting down. I'm going to have the normal force acting up. And I'm going to draw this a little exaggerated. I'm going to fix this there. I have, the force of gravity going down. Then I have the normal force going up. I'm going to draw this larger and then kind of show you why that is, the normal force. And what's happening here, right, is that this delivery man is pushing down on the package. So if somebody were to go onto a scale and push down on you, you would look like you weigh more than you do. And that's what's happening here. So we have FG that's pointing down, and FN is, instead of just counteracting it, it's counteracting that and the push downward from the person. So I also have the force of friction. And then I see that I have a triangle here, so I'm going to go ahead and break that up into components. I have, it's an applied force, so FA in the X direction, and then this would be going downward, FA in the Y direction. And I'm going to go ahead and make myself a little list. I have the mass is 15 kilograms. I have the applied force, FA, is 85 newtons. The angle, theta, is 25 degrees. Assume that it's moving at a constant velocity. That tells us the acceleration in the X direction, and the acceleration in the Y direction is 0. It wants us to find the normal force. And the coefficient of friction. All right. So next step, I'm going to do the sum of the forces in the Y direction. And this is where we have kind of fallen off a little bit in class. We have Fn pointing up, and then it's minus the forces going down. So we have minus Fg. And I saw a lot of people putting a plus Fa because it's and Fa. But minus Fg and Fa like this. You could think of it like that. You have to have the parentheses here. Or you could think of it as Fn minus Fg minus Fa. Minus is before anything that's going down. I actually really like the second way better. You're going to get the same answer either way. This will equal 0. The sum of the forces in the X direction, we have hold on. I wanted to make sure I put a Y here. FA, Y. It's not all of FA. It's only FA in the Y direction. So let's just fix that up. This one we have FAX. That's one that's pointing to the right. Minus FK. That's pointing to the left. And this will also be equaling 0. Again, because of the constant velocity. So that's where I put these numbers on the list for. That's how we got that these are both equal to 0. Now I'm going to do my work to find Fn. Before I start seeing if I can solve, let's see what I know. Do I know Fg? Sure. I know M, and I know G. M is 15, G is 9.81. Do I know Fa? Not yet, but I can find it. I have the hypotenuse and the angle, and Fa is the opposite side. So I'm going to go ahead and rewrite that as the correct equation. So I'm going to go ahead and pull this down here, just so I have some more room. Fn is going to be equal, and I'm going to add both these on the other side, Fg plus Fa in the Y direction. Hopefully you can see how I did that. And now instead of FG and FAY, I'm going to substitute in the equations. MG plus the hypotenuse of the triangle, or FA, and this is the opposite side, so I'm going to use sine of theta. I have 15 kilograms times 9.81 meters per second squared plus 85 newtons sine of 25 degrees. See if I can remember all that. I think I did it. All right. And we got 183.07. Excellent. So I have that answer. And now I'm going to find the coefficient of friction. So I'm going to go ahead. I know the coefficient of friction, right? I have Fk is equal to mu k times Fn. To solve for mu k, I'm going to divide both sides by Fn. Oh. Mu k is equal to Fk divided by Fn. Now, I just calculated Fn. I have that right here, so I'm good there. Check. But Fk, I do not know yet. I'm going to have to use... Oh, I undid my check. I want to undo my good work. But to find Fk, I'm going to have to use the x equation to solve for Fk. The good thing is that I can find Fk because I know Fax and this equation is equal to 0. So let's go ahead and just do the work to find that. So I have Fax. I skipped a step there. Minus Fk is equal to 0. So if I just add Fk on both sides, I have Fax is equal to Fk. And I can easily rewrite this as Fk is equal to Fax. Now, just showing you here that Fax is on the adjacent side. So I'm going to say that's the hypotenuse, or Fa, cosine of theta. So I have 85 cosine of 25. Oh, better clear that. I get 77.036. Newtons. All right. So now I have Fk. Boom. I can go ahead and solve this problem. So I have 77.036 newtons up top. Then I have divided by, and on the bottom I have 183.07 newtons on the bottom. My newtons cancel out to give me no units, which is exactly what I'm looking for. Can I just pull this? Copy. I don't know if it's going to let me paste. I'm not sure how to... Okay. So it's going to be the answer. Then divided by the 183.07255522. And do you notice how I put everything in there just to give me a better rounded answer? So I get 0.4207, and I'm going to round that to 0.421. All right. And that is my final answer.